In this video, we shall look at integration by parts as one of the techniques of integrating functions. So we are talking of a function that is a product of two functions, and these functions are u and v, and u and v are again functions of x. That is, if you have f of x or if you have y is uv, where y is a function of x, then we can differentiate f of x is equals to uv, and we get the integral, the derivative of f of x is equals to the derivative of u times v plus the derivative of v times u. We can also write it as duv of x is equals to v du dx plus u dv dx. We can somehow ignore dx and write it as duv is equals to v du plus u dvx. If we integrate both sides, we shall get the integral of du v is the same as the integral of v du plus the integral of u dv. And the left-hand side, if you integrate, you'll be left with u v. And the right-hand side, we leave it as the integral of v du plus the integral of u dv. If we make the integral of u dv the subject, then we shall have u v, and then we take this to the left-hand side minus the integral of v du. For example, if you have this, the integral of x sin x dx, whereby we are saying the function f of x or y is the same as x sin x. So this is made of two parts, or it's a product of two functions, x and sin x. So we let our u dx, and then if you differentiate, you get du dx. So we are using this. So u is x, and therefore dv will be sin x dx, sin x dx. So when you have that, then to get v, we need to integrate the left-hand side, and of course integrate the right-hand side. If you integrate dv, you get v, and if you integrate sin x with respect to x, you get negative cos sin x, of course, plus the constant of integration, because this one is an indefinite integral, and therefore the integral of x sin x with respect to x, if you use the formula u v minus the integral of v du. Remember, our u is x, and now we have seen our v is negative cos x, and this plus c, we shall add it at the end, minus the integral of v, remember v is negative x, is negative cos x, but since we have negative here, and now our v is also negative cos x, so this sign we can change it to plus v cos x du. Remember, our du was dx, and therefore we get equals minus x cos x minus x cos x. If you integrate cos x, you get plus sin x, of course, plus c. In fact, even this one we should add a c because of this c here, plus a constant, this still a constant c, and therefore we have a final solution as sin x minus x cos x plus c. That is the integral of x sin x with respect to x. We get sin x minus x cos x plus c, since it is an indefinite integral, and that is the technique integration by parts.